Okay, let's go over a little graphical analysis here. What you're looking at, the blue and the black are functions, position functions. The red and the purple are their respective derivatives or velocity functions. So the red is the derivative of the blue, the purple is the derivative of the black. So let's go over what we already know. When the position is increasing, velocity is positive. When the position starts to decrease, velocity is negative. When the position here increases, velocity is positive. When it decreases, velocity is negative. On both of these, you can see that the velocity is decreasing constantly because, what do you know if the velocity is decreasing? You know that the acceleration is negative. And you know the acceleration is negative by looking at the position function because it's concave down on its entire domain. Both of them are. So the other biggest problem you guys have is speeding up and slowing down. So let's talk about that. As you can see, the acceleration is negative for the whole thing. The velocity is decreasing on the whole domain. But let's look at the table of values. Remember, speed is the absolute value of velocity. So remember, red is velocity. So if we look at the table and we go to I just want to look at the red ones. Keep going there, big guy. This is ridiculous. I'm going to go second, table set. I guess you can see it. Okay, stop. Please stop. Ay, ay, ay. Good news is I can edit all this out of my video. Oh, this is driving me crazy. Ay, 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 ay. Okay, here we go. Notice. Now remember, we already know the acceleration is negative because the position function is concave down. Here you can see that the velocity is positive. Velocity is positive. It's greater than 0. So when the velocity is positive and the acceleration is negative, what do you know about speeding up and slowing down? Well, we said in class when velocity and acceleration have opposite signs, the object is slowing down. We also know that speed is the absolute value of velocity. If you take the absolute value of all these numbers, it's going down. The absolute value is decreasing. So therefore the particle is slowing down. So go back to the graph. From here to here, the particle is slowing down. Now what happens starting here? Sorry, I should do this over here. What happens starting here? Well, now the velocity is negative below the y-axis, and the acceleration is negative because the function is concave down. So from here to here, the particle would be speeding up because they both have the same sign. Now let's go look at the absolute value, starting at -2. Notice here, ay, ay, ay. If I take the absolute value of these numbers, they all become positive, and it's increasing, and therefore the particle is speeding up. Now let's look at the other function. Again, it's concave down on its entirety, so you know the acceleration is negative. Here the velocity is positive. They have opposite signs. This particle is slowing down until t equals 3. From here, from 3 to 5, the particle will be speeding up because velocity and acceleration have the same sign. Velocity is negative, acceleration is negative. But again, let's look at the absolute value of the velocity. So we're talking about the purple one. From 0 on, it's slowing down. The numbers are going down. And then we said it changed at 3, I think. And you can see starting at t equals 3, the absolute value starts to increase. So the particle starts to speed up. Okay, now we're going to talk about what happens when the acceleration is positive. Notice both of these functions are concave up, which means the acceleration is positive. I shouldn't have to show you the velocity function. You should be able to picture that the velocity is negative until here because the position is decreasing, and the velocity turns positive here. So I think I'm actually going to turn off the, oh no, because I want you to see that the absolute values increase and decrease. So you should be able to tell that the function is slowing down until here. The reason is acceleration is positive because it's concave up, but velocity is negative because it's below the y-axis. They have opposite signs, therefore the function is slowing down. The particle is slowing down. From here, which is about x equals negative 2, to x equals 0, the particle is speeding up because acceleration is positive and velocity is positive, the same sign. And again, if we go back to the absolute value of the velocity, you can see that from negative 4 to negative 2, why didn't that work? Oh, mama. From negative 4 to negative 2, the velocity is, the absolute value of the velocity is decreasing, therefore it is slowing down. And from negative 2 to 0, the absolute value is increasing, and therefore it is speeding up. Absolute value is increasing, speeding up. Now to the last section. You can see that the velocity is negative and the acceleration is positive. So this function is, I keep saying function, I mean particle. This particle is slowing down until here, at which point the velocity becomes positive, the acceleration is positive, therefore the object is speeding up. And if we look at the absolute value of the velocity from 3 on, remember absolute value, or the velocity is purple here. It is increasing, therefore the function, the particle is speeding up.